Hi friends, welcome back. We have seen the theory part of Chemical Kinetics chapter in our previous videos. In this session, I am going to solve some of the numerical problems of this same chapter, Chemical Kinetics. So welcome. Let's start with the first question now. Now the question number 1. Given 2NO plus O2 gives 2NO2. The rate is equal to K into NO square O2 power 1. By how many times does the rate of the reaction change when the volume of the reaction vessel is reduced to 1/3 of its original volume? So let's solve this. Well, in this problem, they have mentioned an elementary reaction and it is 2NO plus O2 gives 2NO2 and the rate of this reaction is given as K into concentration of NO square into concentration of O2 power 1, and it is mentioned that volume is reduced to 1/3 of initial volume. Remember, whenever there is a change in volume, there is a change in concentration. Upon increasing the volume, concentration decreases, and on decreasing volume, concentration increases because they are inversely related to each other. Now that the volume is reduced to 1/3, we must understand that this concentration of NO is reduced by 1/3 of the volume. Again, O2 is also reduced by 1/3 of the volume. So what happens to the concentration? There must be increase, and that is given as K into 3NO square into 3O2. So take these constants 3 out so that they become 3 square. 9 into 3, 27. 27 times K into NO square into O2. And we can understand that this is the initial rate. This is the initial rate. So what do we get? 27 times the rate. So answer is rate increases 27 times. So have a look at it again. We will take the next problem. During an elementary reaction, 2A plus B gives products. The rate increases 2 times when concentration of B is doubled, and the rate increases 3 times when the concentration of A is increased 9 times. What is the order of reaction? So we need to calculate the overall order of this reaction. Let's see. Well, it is given the reaction is 2A plus B gives products. Now for this reaction we need to assume a rate equation. Let's say rate is equal to K into concentration of A power X. Because we don't know the order with respect to A, let's take it as X, and concentration of B power Y. So let this be the actual rate of reaction experimentally determined. Now let's apply the condition. Condition number 1, it says the rate is doubled when the concentration of B is increased 2 times. So rate becomes 2R when the concentration of B has changed 2 times. So 2B power Y. Take this 2 outside, then you will get 2R is equal to 2 power Y into K into A power X into B power Y. Now this term is again R, that is rate. So R here and R here, they get cancelled. So we get 2 is equal to 2 power Y. From this information we can conclude that Y is equal to 1. Okay, apply the next condition. Condition number 2. So according to that, the rate increases 3 times, that is 3R is equal to K into concentration of A, but A here is set as increased 9 times. So I take 9 times A power X into B power Y. Okay, take that 9 out, then you get 3R is equal to 9 power x into k into concentration of a power x into concentration of b power y. So once again do the same thing, that is r is cancelled with this term which is again r. Then we got 3 is equal to 9 power x. From this we can understand that x must be a square root. Square root is nothing but half. So x is equal to 1 by 2. I got the values of x and y both. Now the order of this reaction is x plus y, which is equal to 1 by 2 plus 1, which is 3 by 2. So this is the overall order of reaction. Let's take question number 3. A first order reaction is half completed in 693 minutes. Calculate the time required for 70% completion. Okay, let's solve this. It is given as first order reaction for which the rate constant and half-life have a relation that K is equal to 0.693 by T half. This is for a first order reaction. Therefore, I get the value 0.693 divided by 693 minutes. So the answer becomes 693 get cancelled, 10 to the power minus 3. This is because I just shift this decimal point 3 times to the right. It becomes 693 into 10 power minus 3 by 693. So 10 power minus 3 per minute is the value of K that we obtained from this information. Using this, we want to calculate the time required to complete 70% of the reaction, for which I will consider the equation of rate constant, that is 2.303 by T into log of concentration initial by concentration at the time T. So T is equal to, cross multiply these two terms, you will get 2.303 divided by, take the value of K from here, that is 10 power minus 3 into log of R0 will be 100%, that is initial concentration, and it's given as 70% completion, so 100 minus 70. Then I'll simplify this, 2.303 by 10 power minus 3 into log of 100 over 30, and 100 by 30 has a value 3.333. That 3 is a recurring number. Next, log of this value 2.303 divided by 10 power minus 3 into 0.5228. This you can try with the help of a simple calculator with some formula. Otherwise, look into the log book, you will get the correct answer. Then next is, we want to multiply these two values and find out the final answer. Into 10 power 3, which becomes 1204 minutes. This is the final answer, that is time taken for the completion of 70% of the reaction. Yes, here is the next problem. The rate of a reaction increased by 2 times when the temperature of the reaction is raised from 300 Kelvin to 310 Kelvin. Calculate the energy of activation of the reaction. And R value is given 8.314 joule per Kelvin per mole. Let's try this. So let's consider the equation to calculate activation energy. It is Arrhenius equation where we have log of K2 by K1 equals EA by 2.303 R into, if I remove this minus, it becomes T2 minus T1 by T1 T2. Okay. Now let's substitute all the values. According to the data, rate constant, rate increases 2 times, so it becomes 2 times K1 by K1. yes, which is equal to EA by 2.303 into 8.314 and into 310 minus 300 by 300 into 310. Okay, let's simplify further. This K1 gets cancelled. Only log 2 is remaining, which is 0.3010, and that's equal to EA by 2.303 into 8.314 multiplied by 10 by 93,000. So this is the value. Finally, EA is equal to 0.3010 into 93,000 into 2.303 into 8.314 whole divided by 10. So we get the final answer here. So the final answer is 535,985.946 by 10, which becomes this, that is shift 1 decimal to left, then divide by 1000, you will get 53.598 kilojoule. Rate constant of a first order reaction is 0.00693 per minute. Calculate the percentage of the reactant remaining at the end of 60 minutes. Okay, let's use the equation of rate constant of a first order reaction. It is K is equal to 2.303 by T into log of R naught by R. Okay, we got the value of K 0.00693, which is equal to 2.303 by time given is 60 minutes into log of concentration of R is 100 and R will be 100 minus X. Let us say X is the percentage of reactant completed. Now cross multiply everything, you will get log of 100 by 100 minus X is equal to 0.00693 over 2.303 into 60. Okay, the product of this is 0.1805. You can do the calculation, you will understand it better. Then next I want to calculate anti-log. I want X value, so 100 by 100 minus X is equal to anti-log of 0.1805, and this value is 1.515. Then do the simple calculation now. 100 is equal to, cross multiply, you will get 151.5 minus 1.515x. Take this to RHS and this to LHS, you will get 1.515x is equal to 151.5 minus 100 becomes 51.5. Therefore, my X value is 51.5 by 1.515. When you do this division, you will get the answer. This is 33.99, and therefore I can say this is 34% completed. 34% of the reaction is completed in 60 minutes. This is the answer. Let's solve one more question. It is, show that for the first order reaction, T 87.5% is equal to 3 times T 50%. Yes. Let's take the ratio of these two times given. That is, I'll consider T 87.5% by T 50%. Since this is a first order reaction, I'll take 2.303 by K into log of 100 by 100 minus 87.5 will be 12.5. Then in the denominator, we will have 2.303 by k into log of 100 by 50. So this is the equation. Now they get cancelled, these two values. Then I got log 100 minus log 12.5 divided by log 100 minus log 50. This is based on the principle of logarithm. Now the values are log 100 is 2 simply, minus log 12.5 is 1.0969 divided by 2 minus 1.6990. So these are the log values. The ratio becomes 0.9031 by 0.301. Now the ratio is very simple, 3 and 9. So definitely you will get 3.00 etc. And that proves that T 87.5% is equal to 3 times T 50%. Here is the proof. One more idea is there, that is, if you have 100% in the initial stage and after first half-life it is reduced to 50% and the remaining is 50%. For the second time it reduces to 25%, which means 75% is completed. For the third time, that is third half-life, it reduces to 12.5%, which means it is 87.5% completed. That means half-life for 3 times will complete the reaction to an extent of 87.5%. So this is the proof. Well friends, if you are using your simple calculator, there is a way to calculate the log of any given number. All you need to do is consider that number, dial this number on your simple calculator and apply these functions. First, do 15 times square root, dial 15 times square root, then subtract 1 in it, minus 1. So I'll write like this, minus 1, then divide it by 0.00007027. You will get the answer. You will get the log of the number. Okay, for example, if you know log 2 you want to calculate, then all you need to do is dial 2, then 15 times square root, then subtract 1, then divide by 0.00007027. You will get the answer 0.3010. Try this, you will get the answer for sure. Okay, that's all for this session. For some more numerical problems, watch my next video. Thank you very much.